Welcome to PicoScope 7, a year in under 12 minutes. In this video, we'll look back at major new features that have been added to PicoScope 7 software throughout 2024. They include triggering, measurement and math, serial decoders, annotations, keyboard shortcuts, command line batch conversions, under the hood, user experience improvements, and finally, what's coming in 2025. The screenshots shown in this video are from the Windows version of PicoScope, but unless noted otherwise, the new features apply equally to the Linux and Mac versions of the software as well. Let's start with the additions of the PicoScope trigger system. In this section, we are going to look at rise and fall time trigger, trigger hold off, pulse width and window pulse width, and dropout and window dropout. Rise and fall time trigger. Rise and fall time trigger, also referred to as slope or slew rate trigger, measures the time a signal takes to transition between two voltage thresholds, from a lower threshold to an upper threshold in the case of rise time, or the opposite in the case of fall time. The scope triggers when the measured transition time meets a user-specified time condition. These are greater than, less than, inside a range, or outside a range of times. Rise and fall time triggering can be set to trigger specifically on rising edges or on falling edges which meet a time condition. This has several applications, including checking that a digital circuit complies with controlled slew rate logic design rules or meets EMC criteria. Trigger hold off. Trigger hold off is an adjustment to set the delay period after a triggered acquisition, during which the oscilloscope cannot trigger again. Complex waveforms can be difficult to reliably and repeatably trigger on. For example, when looking at a burst of pulses, the standard edge trigger might fire on any rising edge within the burst. This results in a flickering display of overlaid waveforms that are difficult to view and not meaningful in terms of the behavior of the device under test. Trigger hold off allows you to set a period when the scope won't look for further trigger events after each triggered acquisition, effectively extending the oscilloscope dead time between acquisitions. By increasing the hold off time to greater than the length of the pulse train, you can ensure that the oscilloscope triggers correctly each time. Pulse width and window pulse width. Pulse width and window pulse width triggering now offer either, in addition to positive and negative polarity triggering. Dropout and window dropout. Dropout and window dropout trigger types now include direction or location. An example of when this is useful is when debugging an I2C bus. If the bus stays high, that is the default state of the bus when no information is being communicated. If the bus stays low, it might indicate that the bus has latched low, a fault condition that would need to be isolated and analyzed. Measurement and math. The measurements and math development team have been working overtime this year. Building on the dual channel, phase and delay measurements previously introduced, AC power measurements that are critical in today's power distribution networks have been added. These include true and reactive power, apparent AC power, power factor, and crest factor. With the focus on efficiency in modern power transmission systems and converters, engineers need to understand precisely the energy consumption characteristics of their designs. Waveform area measurements enable energy measurements to be made cycle by cycle over a given period of time, ideal, for example, for showing startup characteristics of electronic drives and other devices. Other new measurement and math features are measurement pass, failure limits, and actions. PicoScope 7 offers pass-failure limits for any measurement. This gives a visual indication within the measurement lozenge whenever the signal goes above and/or below a specified value. Pass-failure limits can be combined with actions to alert the user or utilize other actions when a measurement threshold has been exceeded above and/or below set limits. Actions include stop the capture, save waveform to disk, play a sound, trigger the signal generator, run an external application or script. So, for example, the instant a measurement falls out of specification, measurement pass, failure limits, utilize actions to save the waveform file and trigger a debugger so that circuit failures can be correlated with specific points of program activity. This automation can also be used to streamline production testing activities, saving valuable time. Finally, PicoScope 7 gives the option to filter captured waveforms within the Waveform Navigator to only show waveforms that have either passed or failed the specified measurement limits. Measurements logging. PicoScope 7 allows results of measurements to be recorded to a file for later analysis. The resulting log can be used to characterize the performance of a circuit over medium or long duration tests, such as when evaluating drift due to thermal and other effects, or can be used to check functionality against an externally controlled variable such as supply voltage, etc. Serial decoders. The number of serial decoders included with PicoScope has grown. 40 protocols are now included as standard. The most recent additions are CAN-XL, the third-generation Controller Area Network Protocol, building on and supporting backward compatibility with classic CAN and CAN-FD networks. It is targeted at in-vehicle networks, connecting multiple controllers and sensors using a single differential mode bus. The other additional decoders are 10BASE-T1S, an Ethernet physical layer standardized by the Institute of Electrical and Electronics Engineers, IEEE, designed to provide 10 megabits per second communication over a single twisted pair of wires. This makes it particularly suitable for environments where space and weight constraints are critical, such as in automotive networks and industrial automation systems. PSI-5 and CENT-SPC, serial communication protocols that are commonly used in the automotive industry for connecting sensors and actuators to an engine control unit, ECU, or other control systems in vehicles. NMEA 0183 is a UART-based protocol for communication between marine electronics devices such as echo sounder, sonars, anemometer, gyro compass, autopilot, GPS receivers, and many other types of instruments. Differential Manchester encoding, DME, is a technique similar to Manchester encoding used to convert digital data into a format suitable for transmission over a physical medium like a cable. It's a type of line code that combines data and clock signals into a single self-synchronizing two-level data stream. Annotations. Annotations are used for placing in-graph notes, along with arrows to highlight and explain specific waveform events, features, or anomalies. These can be documented and shared as images printed or saved within the PS data file. Keyboard shortcuts. Keyboard shortcuts provide an efficient and intuitive way to interact with PicoScope software. You can choose between a basic set of shortcuts, or dive into the full advanced set for comprehensive control over channel ranges, time base, sample rate, trigger settings, and more. Command line batch conversion. Command line batch conversion is an efficient way to convert multiple PS data format files to CSV text or MATLAB file formats. Under the hood, Performance improvements have sped things up and enabled PicoScope to handle bigger arrays of data, for instance 40,000 waveform buffers. Compatibility updates have been made to take advantage of the latest PC processor, display, and operating system technologies. User experience improvements. Alongside these larger updates, there have been numerous improvements to user experience, all based on feedback from our users. These include: directly navigate to the serial decoder setup page when selecting decoder type. Export serial decoding data within Actions. More panel tools are now grouped and organized alphabetically to help you find the tool you need easier. Zoom overview now closes on full zoom out, and horizontal zoom now uses mouse wheel trackpad scroll on Linux. The exact sample rate and interval are now shown in the time-based options panel. User file names are now retained after saving or loading files. What's coming next? Great features and improvements coming in early 2025 are rise and fall time measurement math channels, serial decoding advanced filtering, demo mode improvements, tracking rulers, measurement graph indicators, plus lots more. Thank you for watching this PicoScope 7 software video. For more great software videos, head over to picotech.com.